Hello, welcome to my YouTube channel, Math World with SK. Okay, so today I want us to look at a question from Addma, paper 2, addition mathematics. So we have ECZ Addma paper 2, 2017 August, question 1. Question says, solve the following system of equations. We have the first question, x plus 2y plus 2z equals 4, 3x minus y plus 4z equals 25, 3x plus 2y minus z is equal to negative 4. Okay, so to solve these equations, when you look at them, they are equations in three variables where we have x, y, and z. So to solve them simultaneously, we're going to eliminate one letter first so that we remain with equations in two variables where we can only have, if it's x and y, remain with x and y. If it's y and z, remain with y and z. Then after finding the values of y and z, that's when we can solve for x. If we start by eliminating y, we solve x and z, then we find the value of y afterwards. Okay, so to eliminate one variable, I'll first get two equations. Okay, so I can say this is equation 1, equation 2, and equation 3. Okay, so looking at these equations, I think I can start by eliminating x. So I can get equation 2 and 3. Since I have 3x for both, then we have 3x minus y plus 4z equals 4 equals 25. Then 3x plus 2y minus z equals negative 4. Okay, so I've gotten these two equations and I'm going to solve them simultaneously. The first thing we need to do is to remain with two variables. So eliminate one, remain with two variables. So we're going to eliminate x. And when I look at these questions, solving them simultaneously, I can simply subtract. When I subtract them, x will be eliminated because 3x minus 3x will give me a 0. Then here I have negative y minus positive 2y. So it's like I have negative 1 because the coefficient of y there is 1. So it's negative 1. Then I'm subtracting that minus positive 2. So it's negative 1 minus 2, which gives me negative 3. So I'm going to have negative 3y. Then here I have positive 4 minus negative z. The coefficient of z there is 1. So I have something like 4 minus negative 1. So minus times minus will give me plus. So I have 4 plus 1 giving me 5. So here I have positive 5z equals 25 minus 4. Again there it's 25 minus 4. So negative times negative is positive, meaning I have 25 plus 4 giving me 29. Okay, so the new equation that I have with two variables is negative 3y plus 5z equals 29. So this can be equation 4. Okay, then we can get another one. We left x plus 2y plus 2z equals 4. Even this one, we have to convert it to an equation in two variables. So we need to eliminate x since we've eliminated x here. So I can compare it to n of the two. So if I get x plus 2y plus 2z equals 4, which is equation 1. I can deal with it with equation 3, or you can deal with it with equation 2. It's okay. Let me get equation 3. I have 3x plus 2y minus z equals negative 4. Okay, so here my aim is to eliminate x. Now when you look at the first equation, the coefficient of x is 1. Then the second equation, the coefficient of x is 3. So that cannot give me a 0. So I need to make the coefficients to be the same. Since I have a 3 and a 1 there, I can have a 3 there by multiplying 3 by that equation. I need to multiply this 3 by all the terms in this equation. So 3 times x will give me 3x. 3 times 2y will give me 6y. 3 times 2z is 6z. 3 times 4 is 12. Then here I can write it the way it is. 3x plus 2y minus z equals negative 4. Okay, so what I wanted has happened, where I have the same coefficient. Okay, 3x. Now I can solve simultaneously. Since they're both positive, I use minus. So that 3x minus 3x gives me a 0. Then 6 minus 2 will give me a positive 4y. 6z minus z. So the coefficient here is 1. It's like 6 minus 1. Minus times minus will give me plus. So it will be 6 plus 1. Giving me 6 plus 1 is 7z equals 12 minus 4 will be minus times minus, giving us positive. So 12 plus 4 is 16. So equation 5 is 4y plus 7z equals 16. Okay, now I can get equation 4 and equation 5. So equation 4 is negative 3y plus 5z equals 29. Then equation 5 is 4y plus 7z equals 16. Okay, so what I wanted has happened. I've remained with equations which have two variables, y and z. Now we can solve them simultaneously. Okay, so looking at the coefficients, if I wanted to eliminate y, the coefficients are not the same. If I want to eliminate z, the coefficients are not the same. So I need to make the coefficient of one of the terms to be, one of the variables to be equal, to be the same. So if I choose to eliminate y first so that I find the value of z, I can simply swap these, where I multiply this equation by 4, then the second equation by 3, like that. Okay, so what I've done is I've only swapped these because I want to eliminate y and I want these terms to have the same coefficient. So I've swapped. This 3 is multiplying this equation, the terms in this equation, then this 4 will multiply the terms in that equation. So 4 times negative 3y will give me negative 12y. Then plus 4 times 5 is 20z. 4 times 29 will give me 4 times 9 is 36. I remain with 3. 4 times 2 is 8 plus 3. I have 11. So 116. Then the next equation, I multiply 3 with all the terms in the equation. 3 times 4 is 12y. 3 times 7 is 21z. 3 times 16 will give me 3 times 6 is 18. Remain with 1. 3 times 1 is 3 plus 1 to give me 4. So 3 times 16 is 48. Okay, so what I wanted has happened. I have the same coefficient here. And when you look at the coefficients, this one is negative, the other one is positive. So for me to get a 0, I need to add. Okay, in the previous steps, for us to eliminate to eliminate x, or to eliminate this term, since they are both positive, I used minus. 3x minus 3x gives us 0. Here, one of them is negative, the other one is positive. So if I subtract, I'm not going to get a 0, I'll get negative 24. So I need to add, so that negative 12 plus 12 will give me a 0. Then here we have 20 plus 21, giving us 41z, equals 116 plus 48. It will give us 6 plus 8, that's 14. Remainder 1. 1 plus 4 is 5 plus 1, 6. Then 1, we have that. So 116 plus 48 is 164. Okay, so I have 41z equals 164. For me to remain with z only, I need to divide both sides by z. So I'll have 41z divided by 41. Did I say I need to divide by z? I need to divide by 41, both sides by 41. Okay, so 41z divided by 41 equals 164 divided by 41. Okay, so 41 into 41 is 1. 1 times z will give me z equals 41 into 164 is 4. So the value of z is 4. Okay, so the value of z is 4. For me to find the value of y, I'm going to get any of the two equations. Okay, I can get this equation or this one. Then substitute z with 4. So let me get 4y plus 7z equals 16. We have 4y plus 7z equals 16. Remember, we found that z is equal to positive 4. So I'll have 4y plus 7. Where there is z, we put 4 equals 16. 4y plus 7 times 4 is 28 equals 16. Okay, so we have 4y plus 28 equals 16. We collect like terms, or we bring in what we call the additive inverse of 28. And the additive inverse of 28 is negative 28. Meaning when I add negative 28 here, it will give me a 0. Then there it will be 16 minus 8. So I have 48 and 4y equals 16 minus 28. Okay, so 16 minus 28 will give me negative 16 minus 28 will give me negative, let's see, 28 minus 16. 8 minus 6 is 2. 2 minus 1 is 1. Now, since we are subtracting a bigger number from a smaller number, this 12 is negative. So I have negative 12. Then I need to remain with y alone. So I have to divide both sides by 4. 4y divided by 4, negative 12 divided by 4. 4 into 4 is 1. 1 times y is y. equals 4 into negative 4 will give me negative 3. So the value of y is 3. Now, we found the value of z and the value of y. So for us to find the value of x, we have to get one of the equations here, the original equations, which has the 3 variables. So if I get the first one, x plus 2y plus 2z equals 4. X plus 2y plus 2z equals 4. Okay, so I need to substitute this y with negative 3, then z with the positive 4, because we found that z is 4. So I have x plus 2 times negative 3 plus 2 times positive 4, which is equal to 4. I have x, 2 times negative 3 will give me minus 6. Then 2 times 4 is 8 equals 4. Okay, I have x, then we have negative 6 plus 8. We are dealing with integers with different signs, so we subtract, then the answer gets the sign of the bigger number. So simply say 8 minus 6. 8 minus 6 is 2. And when you look at 6 and 8, 8 is bigger than 6 and 8 is positive. So the answer is positive 2. I've said we have different signs, so we subtract. We're going to say 8 minus 6, giving us 2. Then when we look at this, 8 is positive and 8 is bigger than 6. So 2 will be positive like that. So we have x plus 2 equals 4. We bring in the additive inverse, we'll have x plus 2 plus negative 2 equals 4 plus negative 2, like that. So 2 plus negative 2. Here we're going to have a minus because positive times negative is a minus. So it will be x plus 2 minus 2 equals 4. Positive times negative is minus 4 minus 2, like that. This one will give us a 0. So we have x equals 4 minus 2 is 2. So we found the value of x. So the answers are x equals 2, y equals negative 3, and z is equal to positive 4. When you substitute these numbers in the original equations, they have to satisfy all the 3 equations. Okay, for example, we have the original equations are here, and we are saying x is equal to 2, y is equal to negative 3, z is equal to 4. So these are the answers we found. So the first equation, if we say 2 plus 2 times y negative 3 is negative 6. So it will be 2 minus 6. Then 2 times 4 is 8. So it will be 2 minus 6 plus 8. 2 minus 6 will give us negative 4. Negative 4 plus 8 will give us positive 4. Then here will be 3 times 2, which is 6, minus 4. Minus 3, it will give us plus. So it will be 6 plus 3, then plus 16. 6 plus 3 is 9. Then 9 plus 16 will give us 25. Here we have 3 times 2 giving us 6, plus 2 times y, which is negative, so it will be 6 minus 6, which is 0. Then here minus z is positive 4. Negative times positive, it will be negative 4, which is there. So that's how we deal with such a question. See you next time.